Hey everyone, today we are going to continue our discussion about ratios, and we are going to start using tape diagrams and tables to help us solve ratio problems. So in these first two examples, we are going to create a tape diagram. We're going to do one of each, part to part and part to whole. So in example 1, it says the ratio of smiles to frowns. So right here, smiles to frowns. This is a part to part, because smiles is one part and frowns is the other part, is 5:3. Create a tape diagram to represent the ratio. So when I create my tape diagram, this is a part to part, so I want to know the total number of faces. So here I have 8 total faces between smiles and frowns. So when I create my tape diagram, I'm going to make one long strip here, and then I'm going to cut it into 8 parts. So 1, 2, 3, 4, 5, 6, 7. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 boxes. And this is going to represent the total faces. So my tape diagram should represent the whole. And now I'm going to put in my parts. So there are 5 smiles. So 1, 2, 3, 4, 5, and then 3 frowns. Okay, so the ratio of smiles to frowns is 5:3. So I have 5 smiles, 3 frowns, and 8 total faces. Example 2 says 2 out of 5 students play soccer. So here's my sentence right here. 2 out of 5 students play soccer at LMS. And I want to create a tape diagram that represents 2 out of 5 students playing soccer. So this is a part. This is a whole. So to create my tape diagram, my whole tape diagram is going to be cut into 5 parts. 1, 2, 3, 4. So this is the students, total students. And I've got 2 out of 5 that play. So I'm going to write play and play. And then I've got to write what these other 3 kids do. Well, they don't play soccer. So I'm going to write don't. So it's important that we know the difference between a part to part and a part to whole. So a part to part is just like what we talked about yesterday with ratios. You're given 2 pieces and you can find the whole. And then in a part to whole relationship, you are given a part out of the total number of something. So now we're going to use these tape diagrams to solve ratio problems. So we're going to be able to create these tape diagrams with numerical values to help us solve the ratio problems. So step 1 says determine your parts and your whole and label them. So you'll see in the examples, it says part 1, part 2, and whole. Then we're going to draw a tape diagram from our parts and our whole to represent the ratio. And then we're going to determine how much each section should represent using the information that we're given. And we're going to write that in each box. And then we're going to answer the question. After we create a tape diagram, we are also going to create a table to represent the same information and show how those things are related. So we're going to kind of do 2 examples in one. We're going to create the tape diagram, and then we're going to show how the table and the tape diagram get us to the same place. So example 3 says Mrs. Nichols is buying flavored Tootsie Rolls for her class, and she wants the ratio to be 3 vanilla Tootsie Rolls for every 4 cherry Tootsie Rolls. So here's one of my parts, here's the other part, and my whole is going to be the total number of Tootsie Rolls. So I've got vanilla and cherry, and then I'm going to have total Tootsie Rolls. If she has 42 vanilla Tootsie Rolls already, how many cherry Tootsie Rolls does she need to buy? This is going to be a part to part Even though I know what each of the parts is and the whole is, this is still describing a part-to-part relationship. Vanilla and cherry together make the total. So vanilla is a part and cherry is a part. So now I'm going to create my tape diagram. So I'm going to use black here. And my vanilla is 3, my cherry is 4, so my total is 7. So I'm going to break my tape diagram into 7 pieces. So 1, 2, 3, 4, 5, 6. That gives me 1, 2, 3, 4, 5, 6, 7 boxes. And then I'm going to use a line to separate the cherry from the vanilla. So it's 3 to 4, so this is going to be the vanilla. This is going to be the cherry. Now to figure out what goes in each of these boxes. So up above I have play and don't play. I have smiles and frowns. And the reason why I have that is because they didn't give me a certain number of smiles and a certain number of frowns that I was trying to figure out. So down here they tell me that I have 42 vanilla Tootsie Rolls already. So if I've got 42 vanilla Tootsie Rolls, and I want to split it into 3 parts, I'm going to do 42 divided by 3 because I need to fill each of these boxes with the same number. So 42 divided by 3 is 14. So I'm going to put 14 in each of these boxes. And then because it's a ratio relationship and we're talking about doing something to each part, I'm going to fill the rest of these boxes with 14 as well. And then to figure out how many cherry there are, I'm going to add up everything that's in these boxes, or I can multiply 14 by 4. So it says how many cherry Tootsie Rolls does she need to buy? She needs to buy 56 cherry Tootsie Rolls. This was using a tape diagram to solve this problem. The next thing I'm going to do is I'm going to take this exact same question and I'm going to do it in a table. Because eventually you're going to be able to choose whether you use a table or a tape diagram. To start, we're going to have you do both so that you understand how to use both. And then we are going to move into, you get to pick, do you like tape diagrams or do you like tables? So for my table, I'm going to take my 2 parts and my whole and I'm going to create a table with that information. So I'm going to have vanilla, cherry, and total. And I know that my vanilla to cherry is a 3 to 4 relationship and that the total is 7 because 3 plus 4 is 7. Now I'm going to do the same thing that I did in my tape diagram. I'm going to use that 42, but now I'm going to put that 42 in the vanilla section of my table. And I'm going to say, okay, how do I get from 3 to 42? And you're going to see some of those numbers repeat themselves. So I can see the 3 up here, I can see the 42, and then here's going to be the other piece of information that I'm going to use because I'm going to multiply 3 times 14 to get to 42. So I'm going to do the same thing in the cherry part of my table. I'm going to multiply by 14. I'm going to do the same thing in the total part of my table, and I'm going to multiply by 14. 4 times 14 is 56, and 7 times 14 is 98. And here again is that 56. So whether I use a table or a tape diagram, I'm going to get the same number of cherry Tootsie Rolls. Okay, this was a part-to-part relationship. They gave me the 2 parts, and I created the total column of my table from that information. Example 4 says, a survey showed that 3 out of 7 students in 6th grade like Michigan State. Based on this result, how many of the 140 sixth graders don't like Michigan State? This is going to be a part to whole relationship because they told me 3 out of 7 students, 7 total students, like Michigan State. So part 1 is going to be that they like MSU. Part 2 is going to be that they don't like MSU. And the whole is going to be total students. So in this one, when I create my tape diagram, they've told me that I've got 7 total students and 3 of them like Michigan State. So when I create my tape diagram, 1, 2, 3, 4, 5, 6, I'm going to break it into 7 parts because I have 7 total students. And 3 of them like Michigan State. That means that 4 of them don't like MSU. So that's going to be that information. So now I'm going to use the information that they gave me in the question. So it says, based on this result, how many of the 140 sixth graders don't like Michigan State? So I am going to take those 140 sixth graders and I'm going to split them into 7 equal parts. That's going to put 20 sixth graders in each spot. That means that 60 of them like MSU and 80 of them don't. So I'm going to say 80 students don't like MSU. And now I'm going to do the same thing with the table. So I'm going to have that they like it, that they don't like it, the total. So I know that 3 like it, 4 don't like it, and 7 total students. And then I've got my 140 going in the total column of my table. And then it's the same thing I did in the last question. How do I get from 7 to 140 to make my ratio work? So 7 times 20, and that's where the 20s are. So I can see this times 20 here, and here's the 20s in this box. So that's where the 20 comes from. And then I'm going to multiply each one by 20. So times 20 times 20. 3 times 20 is 60. 4 times 20 is 80. And there's my 80 students that don't like Michigan State. Okay, the first one was a part-to-part relationship. This one is a part-to-whole relationship. Example 5 says the ratio of time a student spends on science homework to the time they spend on math homework is 2 to 5. This is a part-to-part relationship. So time spent on math, time spent on science. I want to list it in the right order. My apologies. Science is first. Math is second. And then I've got total time. Science is 2, math is 5, so my total time is going to be 7. So when I create my tape diagram, it's going to be out of 7. 1, 2, 3, 4, 5, 6. And then I'm going to draw a line where it splits. So this is going to be our science. This is going to be our math. The total amount of time a student spends on homework for these classes is 63 minutes. So they're giving me the total amount of time. So I'm going to take those 63 minutes and I'm going to divide it into 7 parts. So they gave me part to part and then told me what the total amount of time was. So 63 divided by 7 is 9. So 9 minutes is going to go in each one of these boxes. So now I'm going to determine how much time the student spends on homework for each subject. And I've got it broken into my 2 parts. So they spend 18 minutes on science. And 45 minutes on math. Okay, because 9 times 2 is 18, and 9 times 5 is 45. So I'm going to do the same thing, but now in a table. So I've got science, math, total, two to 5, and 2 plus 5 is 7. And then they tell me 63 total minutes. So 7 times 9 is 63. So 5 times 9 is 45. And 2 times 9 is 18. So there's my 18 minutes and my 45 minutes. At this point, I'm going to pause my teaching video. And I will continue in a second video in the effort to keep the video a little bit shorter. So I will do the rest of the examples in a separate video.